Hey everybody, welcome back. This is sections 2.5 and 2.6. So most of the unit that we've been working on has been in chapter 3 in the book, but these two sections actually go into chapter 2. So as you can see, we're talking about angle relationships and special angles on parallel lines. So on this slide, we are looking at linear pairs and vertical angles. We have already defined what a linear pair is and what vertical angles are, but we are introducing two new conjectures. The first is the linear pair conjecture. It states, if two angles form a linear pair, then the measures of the angles add up to 180 degrees. The vertical angle conjecture states, if two angles are vertical angles, then they have equal measures, or in other words, they are congruent. Now, these two conjectures are pretty self-explanatory. You probably already knew these two things. Most of the time, students assume these two conjectures to be true simply based on the definitions of what a linear pair is and what vertical angles are. But we are now officially conjecturing that these are indeed true. They are simply conjectures at this time. Moving forward in the course, we will at some point prove these to be true. I would definitely write these down in my notebook so that I can refer back to them. And these are two conjectures that you need to know moving forward. All right, next we're going to define the converse. And we've already talked about this in class, but this is sort of the official definition. The converse is a statement created by switching the if and then parts of a conditional statement. And we are asked a question here. Is the converse of the vertical angles conjecture true or false? Well, let's go back real quick. The vertical angles conjecture at the bottom, if two angles are vertical angles, then they have equal measures. Or in other words, they are congruent. So if we took the if part of this statement and the then part of this statement, and we switched them, we would end up with the converse. If two angles are congruent, then they are vertical angles. And the question here is this converse true or false? It, of course, is going to be false. Because just because two angles are congruent does not mean that they have to be vertical angles, right? We can have two completely separate angles, and they can be congruent angles and not be vertical angles. All right, next I'm going to walk us through some very important vocabulary on the special angles on parallel lines. I would definitely write this down in my notes, and vocabulary is always important. A line intersecting two or more other lines in the plane is called a transversal. A transversal creates different types of angle pairs. And I will show you what a transversal is after we define all of these terms. Corresponding angles have the same general location with regards to the respective parallel line and intersecting transversal. Next, we define alternate interior angles. They are angles contained inside the parallel lines on opposite sides of the transversal. Then we have alternate exterior angles. They are angles contained outside the parallel lines on opposite sides of the transversal. And lastly, we have co-interior angles. They are angles contained inside the parallel lines on the same side of the transversal. Now that you have these written down in your notes, you can refer back to them anytime you need to especially on the next slide here. All right, so let's put those vocabulary terms to use. Given that lines E and F are parallel and cut by transversal T, identify all pairs of corresponding alternate interior, alternate exterior, and co-interior angles. So if you need to review your definitions, certainly do that. But let's get started here. So we can see lines E and F, and they are parallel, and they are being cut by transversal T. So you can see how the transversal intersects the two parallel lines. So let's start with our corresponding angles. So we're going to list all the angles that are corresponding. So corresponding angles have the same general relationship with regard to the parallel lines and the transversal. If I look at angle 1, out of the 4 angles that you see here, I would categorize angle 1 as being to the left of the parallel line E and on top of or to the right of the transversal T. So when I look down at this group of angles, I need to find the angle that is in the same general location with respect to its parallel line and the transversal T. And of course, we can see that angle 3 has that same general location. So we can say that angle 1 and angle 3 are corresponding angles. Using that same concept, we can see that angle 2 and angle 4 are corresponding angles. Angle 6 and angle 8 are corresponding angles. And angle 5 and angle 7 are corresponding angles. All right, next let's look at alternate interior angles. So alternate interior angles are inside of the parallel lines on opposite sides of the transversal. So inside of the parallel lines would be these angles in here. Opposite sides of the transversal, obviously, we have the left and the right. So alternate interior angles would be 2 and 7 and 3 and 6. So angle 2 and angle 7 are an alternate interior pair, and angle 3 and angle 6 also. Then we can go on to alternate exterior. So alternate sides of the transversal, exterior meaning outside of the parallel lines. So now we have angle 1 and angle 8, and angle 4 and angle 5. And last but not least, throw it right here, co-interior angles. Co-interior, meaning they are interior inside of the parallel lines, and co-interior, meaning they are on the same side of the transversal. So 2 and 3, and 6 and 7. So that should give you a good idea of how we apply those definitions of the special angles on parallel lines. All right, so last but not least, we have a couple more conjectures, but these conjectures are all based on parallel lines that are cut by a transversal. So I've taken the 4 different conjectures and just kind of meshed them into one. And this conjecture states that if 2 parallel lines are cut by a transversal, then the following is true. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. And co-interior angles are supplementary. So imagine each of those being their own conjecture. And now let's think about the converse of each of those. So we would simply switch the if part of the statement right here and each of the then parts of the statement that you see here. So the converse would say, if two lines are cut by a transversal to form pairs of congruent, corresponding, congruent alternate interior, or congruent alternate exterior angles, then the lines are parallel. Now you may notice here that we did leave out the co-interior angles because those are never congruent, they are simply supplementary. All right, so that ends 2.5 and 2.6 on special angles of parallel lines. Probably really important that you took some good notes here. Of course, we will do a lot of work with this stuff in class and further explanation ahead.